that you could see the depth of the face without needing any special 3D glasses. Now most people, when they saw this display, would say something like, "Oh wow, these holograms are finally here." So, I mean, so I work at the Institute of Creative Technologies.
Yeah.
And I mean, we've been trying to do 3D graphics pretty much since the Institute was founded, which was back in 1999.
1999. Yeah.
Now, the spinning mirror display, that one I started building, I think, in the summer of 2006.
2006.
Yeah.
Yeah.
So that was the really small,
Small
prototype.
Yeah.
And it wasn't spinning that fast. It wasn't even
Oh.
spinning as fast as the one that you built.
Oh, yeah.
And we just took like a regular video projector and we aimed it at the display, and we're like, oh wait, this idea could work. And then once we made it work, we're like, okay, well, let's build a proper video projector, get the hardware sorted out, and that was probably took like a month or two, and then the rest of the year I spent pretty much figuring out what's the best way to do all the rendering, and then that was a cigarette paper back in 2007. And then we took the same system and we made a new mirror. We had a second video projector in 2009,
Yeah.
and that was we had another cigarette paper, but that was like when we had a live 3D floating head. So, and we could scan someone's head with like structured light and have a conversation with someone on the display. Then the big projector array we built about just over 2 years ago.
2 years ago.
Yeah, and then it's taken us a while to try and get all the bugs out, and it's getting there. It's getting close. That's a good question.
Yeah.
I mean, the main thing is trying to make it, I think, lower cost and more stable, so that like, if someone wants to actually like buy a 3D display or something like that, I think it sort of has to cost like less than $1,000 or like $1,000. I mean, most people couldn't afford to spend like $10,000 on a display.
Yeah.
Right. I mean, it's sort of like buying a fancy television.
Yeah.
So, to begin with, I mean, I think you're going to have to make them smaller and easier to build.
Yeah.
I mean, which is like where I think that the stuff you're doing is pretty cool, because I mean, you're basically trying to see how cheap can we make this.
Thank you.
And make it work. So that's interesting. I mean, there's always two things: you can make it smaller and cheaper, or you can make it bigger.
Yeah, yeah.
And we probably will make it bigger.
Yeah.
But on the other hand, I mean, for me, the important thing is to try and make it so that, like, people who just can like build their own. And I mean, we've put out like the papers, and people can read the papers. But there's a lot of things that like you have to figure out for yourself still. So if there's a way to document that, so people could start playing with this stuff, then that'd be a lot of fun.
Yeah.
I mean, right now people are still sort of thinking like putting like HMDs and things on your head. So maybe people aren't quite ready to like think about, oh wait, you don't need glasses, right? And it's a different type of experience. HMDs, when you put them on, it's like you're transported to another place.
Yeah.
Whereas if you're a 3D spinning mirror, it's like it's bringing something from the digital world into your real world.
It's cool.
Thanks.
So the third question is about what skill do you think is the most important in the development process in your team or your program? Which skill? What is the most you wanted?
I don't know. I think it's really hard for one person to know everything. Like you're not going to be able to be a good do everything. I mean, some people are really good hardware folks. Like if you're an electrical engineer, being able to design your own circuit boards and program motors and do a lot of those things. And I mean, some people are really good at getting hands-on and building things. You also get like really good software developers who are just like can do. I mean, if you're a software guy doing computer graphics, I mean, you need to have a good understanding of the fundamentals of like how do cameras work. I mean, not just like digital cameras, but like I encourage people to go out and like play with real cameras and like know like what aperture is and how lenses work, so that when it comes time to like trying to simulate it in a computer, you can relate it back to the real world. I mean, there are people who are really good at optimization algorithms, like the math of like, you have some function or some problem and you say, okay, this is the error, and then you minimize it and you try and optimize to find the solution. Like if you're trying to do stereo reconstruction, I mean, a lot of the stuff we do in the face, like, is like you have a bunch of cameras and looking at something in the real world, and you want to reconstruct a model, and that basically is an optimization problem. So get the math behind like 3D optimization, or I mean, solving matrices, things like that, is good. So those are sort of the three things: being like comfortable with, I mean, you're comfortable with like building stuff, comfortable with sort of computer vision techniques and like how cameras work, and then just like the math behind like if I'm trying to if I have so much data and I want to reconstruct something from it, understanding the math behind that.
So a lot of things is important, right?
There's a lot of things. I wouldn't expect one person to know everything, because I mean, when you're building something like a 3D display, it's a team project, and different. Like I couldn't build a 3D display by myself. I mean, I knew a lot of the programming side, but I also we had a really good electrical engineer who could do a lot with the hardware and the building of those components. And the same in like this lab, we have electrical engineers and we have computer science people working together. So really, I mean, these sort of things are team projects. And I mean, you said you had a team back in, like friends back in China who were helping build it with you. And I mean, whenever you see like a successful research group, it's usually not just one person by themselves.
So the first question is, what do you think about the laboratory which were doing the similar project with graphic library or ICT?
There are one or two people who I know, like other students who've said like they try to build stuff. There were some people at the Rochester Institute of Technology. It's in New York.
New York.
There's people the students in New York have tried to build one.
It's a company or
they were just like undergrad. They were like students like you. I mean, everyone does it slightly differently. There's I think some professors in Japan. I can't remember their names off the top of my head. There's a research university in Japan that been building some spinning mirror displays.
What do you think about them?
I mean, they're doing great work. I mean, they one of them they built a mirror that it doesn't just spin this way, but it spins this way at the same time. So it's like they called it the dishwasher or the washing machine because it was so loud. And the idea was that it would reflect different images at different heights, but unless you're projecting really really fast, you just flash every couple seconds because it was distributing the frames this way and this way. And there's some people who've done some work with spinning discs. Like you have a disc and that spins.
Discs. Have you ever seen the disc like this?
I haven't seen it as a disc in person. I've only read about it.
Do you know about the Zhejiang University Optic and Electronic Research Institute? Have you heard about that?
I don't know too much about.
Oh yeah, I have visited them's work in the last years.
Okay.
Yeah. Yeah.
What did you think when you saw it?
Oh, I think it's cool.
I think that's
Cool.
even more impressive when like just a student does it. I mean, I think that the key that it's key. I mean, when you're trying to study, like being able to, like, someone being motivated to just think like, hey, this is a cool idea, and I'm going to do it, and then making it actually work,
Yeah.
is a really important skill. Like, it's probably the most important skill. When it comes to, I mean, either it's getting jobs or just getting stuff done. I mean, so, I mean, it's one thing if someone comes along to you and gives it as just like a student project.
Yeah.
And like everyone in the class is doing the exact same thing. But the fact that you have the time and like you're able to manage your time, so you have the spare time to build the thing,
Yeah.
and make it work, is very impressive.
Yeah.
And I mean, I'd love to find out more about exactly how your thing works. I mean, the biggest challenge, as far as if you actually want to make the display like reach its potential, is
Yeah.
I think the video projector.
Which is video projector. Right?
Yeah, because
yeah.
I mean you can build a spinning mirror.
Yeah.
You can write the software.
Yeah.
But the
speed of projector can.
Well, it's not the speed of the projector, but it's the data
Yeah.
transfer to the video projector.
Yeah.
So I mean, you can have video projectors and DLP chips can go I don't know, 20,000 frames per second, right?
Yeah.
They can go really fast.
Yeah.
But if you actually wanted to send 20,000 frames per second to a video projector, you're going to need, I mean, either multiple video streams going to different multiple cables.
Yeah. Or
you need some sort of new standard. So I mean, like with the Lightcrafter,
yeah.
it's that sort of the reason why, like, when you're playing from the local, like, flash memory, you can go really, really fast. You can go 4,000 frames per second.
Yeah.
But when you're streaming it from the computer,
it's very slow.
It's very slow.
Yeah.
And I mean, it's not something that, from a hardware standpoint, is particularly difficult. I mean, you can put faster chips on there to decode the video.
Yeah.
You could add more ports to basically send multiple frames at the same time.
Yeah.
But as far as, at that point, it's no longer like just a product that you can buy off the shelf.
Yeah.
So what you need is like a video projector company that's willing to invest in making that very customized video projector.
Yeah. Yeah.
And it's sort of a catch-22, which is the video projector companies, unless they can like make 1 million of them,
Yeah.
they tend not to do it at all.
Yeah.
But unless, I mean, if you have 1 million people, then everyone would get to see how cool it is. And they're like, oh, okay, we want one. And then, so it's, which is why I'm saying, like, if we can make it cheap,
Yeah.
and use off-the-shelf components, even if it's just showing the same videos over and over and over and over again, then maybe that can build up the interest that could get the video projector companies to like modify a video projector. I mean, like even Texas Instruments, they're really close.
Yeah.
The Lightcrafter can go the right speeds.
Yeah.
It has a lot of the built-in hardware.
Yeah.
It just can't. It just needs faster data transfer.
Yeah. Yeah.
So the data transfer is the biggest issue, and then and making it all cheap enough that people would actually want to like use them.
Yeah. There have another is, do you think the next i3D display will be leading the next tech revolution like VR or AR? If it does, what the barriers should be removed? Like all of them is now necktie 3D display. So what do you think they will be with the next tech revolution like? I don't know if you know the guy named Plum Lucky.
Yeah.
Yeah, he's working in the ICT at the past, right?
He used to. He used to work at ICT before he did his Kickstarter.
Yeah. So what do you think about him? And what do you think?
Well, I never got to meet him.
Oh yeah.
Unfortunately.
Yeah. So what do you think about your naked eyes displays will be that? I think
it could be.
Yeah, it could be. Yeah.
I don't necessarily think that one 3D display, like one type of 3D display, is going to solve every problem. Like, the 3D display is really good at showing things that are like this size. And you can show it to lots of people at the same time, which is really nice.
Yeah.
But that doesn't solve every problem. I mean, if you wanted to show an environment, and like, I want to be standing on the moon, right? Then okay, then I can put it on a head-mounted display and I can be standing on the moon.
Yeah.
But if I wanted to be in a room and I want to be talking to you and you're digital, right?
Yeah.
Head-mounted display doesn't quite get you there because, well, the problem is that if you put on a head-mounted display, it's covering up your face.
Yeah.
So if I'm covering up my face, and I want to be able to show my face to you so you can see me, not wearing glasses is actually a big deal.
Yeah. Which
is why when we show the digital humans on the display and you can talk to them, or we did the teleconferencing on the spinning mirror display, what made it great was that you could see the other person's eyes.
Yeah.
You could look them in the eye, and they could look back at you, and you could have that connection.
Yeah.
So I hope it could be.
Yeah. I hope it could be.
Yeah. I mean, the thing that's changed is that
since you changed.
I mean, you now have digital video projectors. You have digital displays that are getting so much cheaper.
Yeah.
I mean, before you had to be analog, you'd have big LCD monitors, you had to have all these other things that were big and bulky. Yeah. And pixels are getting really small. Yeah. And light and cheap. Yeah. And that's what's making it all work.